focus of this objective is to find the domain and range of functions and use the vertical line test. If you recall, the domain of a function is the set of x values for which a function is defined. And the range is the set of y values for which the function is defined. Well, we can read those if we know what the graph of that function happens to look like. For domain, you want to read the graph from left to right, and basically what you're trying to do is to state the interval of x for which that x value has a corresponding point on the graph. So you can almost think of it if you're running along the x-axis and you're fishing, or whatever you want to think about. Throw out a line, so to speak, and would you grab a point on the graph? If you would, then that number is in the domain. If there's no point on the graph to grab, then that element of x is not in the domain of the function. So let's take a look at this parabola that I have drawn here. So if I want to find the domain of this function, the domain of this function going from left to right, notice that the graph actually extends indefinitely from left to right. There's not arrows there, but it's kind of understood to be there. And so from left to right, this graph extends indefinitely, which means that the domain of that function is all reals, or we could write it in interval notation as negative infinity to infinity. Now, the range of the graph, we change our focus, and this time we're looking for the y values for which there's a corresponding point on the graph. And the easiest way to do that is to read the graph from bottom to top. So think about, where does the graph start in the bottommost direction? Where does it end in the topmost direction? So notice that our graph extends indefinitely downward. So that means that our range begins at negative infinity. And where does it end in the topmost direction? Well, it ends here, right? And we have to state what is that y value there, and it is 4. We include that y value because that point is included as a point on the graph. Now notice why we don't go up above 4, because there's no graph that corresponds to those y values. Now looking at this next graph, it is a square root function. So again, this extends indefinitely to the left. So we're thinking about our domain of this function. The domain is reading from left to right. So what values of x can I grab the graph? Well, as I go to the left, since this continues indefinitely, every value to the left will have a point that corresponds to it on the graph. So it begins at negative infinity, and then we come along and we have to think about, where does it stop in the rightmost direction? And it stops at this point. But what is that x value? That x value is 3. So that would be my domain. Or you could write that with the statement x is less than or equal to 3 would be appropriate as well. Now the range of that now changes my focus. Again, I'm looking from the bottom to the top. Well, from the bottom, my graph is here as well, but I need to find out what is that y value, and it is negative 2. Well, where does it extend or end as I go up? Well, since the graph continues upward, it has no end in the upward direction. It's going to reach those values. It's going to take a very, very negative x value to get way up high, but it will eventually get there. So this range is from negative 2 to infinity. Or I could say this as y is greater than or equal to negative 2. And then my last graph, my domain, again, this is a graph that extends indefinitely from the left to the right. So my domain would be negative infinity to infinity, or all reals. And what about my range? Right, this time I'm looking from bottom to top. but it also extends indefinitely in those directions, so the range is as well negative infinity to infinity. Now, the last thing I just want to review with you, I think we may have even mentioned this in the last section, being able to use the vertical line test to determine if a graph of a relation represents a function. You will recall that a function is defined to be a relation such that every x has what? Yes, only one y value that it corresponds to. Well, we can use the vertical line test to determine if a graph is a function, because a vertical line has the same values of x on it. So if that vertical line touches more than one point on the graph, then it's not a function because it would correspond to more than one y value. So you can run a vertical line across your graph, and if you find a place where it hits more than one point, which we do in this particular graph of this ellipse, then we know that this is not a function. Now, what about the ones that we did up above? I can still talk about the domain and range of a relation, if you will. The domain for this, as I go from left to right, would be from negative 2 to 2. And the range, going from bottom up, is from negative 3 to 3. So that concept still exists because there's still x and y values that we can talk about. But there are more than one x value, or is more than one y value for a particular x value. Now, what about the graphs up above? Were those functions? Yeah, because if I take my vertical line and run it across my graph, notice that I'm only touching one point. I go to this next graph, it only touches one point on the graph. And lastly, this polynomial only touches one point on the graph. So all of those are functions. Okay, so if you have questions on this, don't hesitate to contact me.